So now let's talk about equation-driven curves. So in SolidWorks, you can actually create curves which are driven by equation in 2D as well as 3D. So let's start with sketch, and I'll just create a sketch on maybe front plane. All right, now here, instead of just using these traditional methods, I'm going to go to this drop down and I'll select equation-driven curve. Now here we can write an equation and SolidWorks will generate the curve. So we have two options for writing the equation. We can actually use an explicit equation or we can use parametric. In explicit, we can specify equation in one single variable. In parametric, you can use two different variables to express the equation. I'll start with explicit, and here let's use one of the simplest kind of equation, and that is sine of x. Now in this case, this is one of the simplest equation, and now you can specify the range of this x here in the parameters. Let's say the range of x is from 0 to 30. Now for this value, we'll get this equation and it will show the equation right here. So if the value of x changes between 0 to 30, then the equation that we'll get will look like this. Now you can make it even more trickier by adding more variables. For example, here let's add 6 times, and that's going to increase the amplitude. So I'm going to type 6 multiplied by sine x, and here we are. So for the same value, we are going to get this equation. Now, as you can see, the crest and troughs are kind of, well, higher and lower than the previous one. Now, in a similar way, you can create different kind of equations. For example, now let's say we want to create a curve where the peaks are high and then low, then again high, then low, and something like that. So that's a kind of equation which we want. And I've actually created some equations for making these curves already. So here, this is the formulas txt file, which is available with the download files. So you can just use this to add the equations. So here I'll use this sine alternating formula for this, and I'll just simply copy this and I'll paste it here. All right, now with this formula within the range of 0 to 30, this is the kind of curve which you're going to get. As you can see, higher crest and then the lower one, higher, lower, and so on. Now, once you click OK, you'll get this 2D sketch, and you can actually convert it into 3D as well if you want to. So here, maybe I'll just make a close profile from this simply by moving it like that. And maybe I'll just make it completely horizontal and done. Now, if you, let's say, want to extrude it, or maybe if you want to revolve it, you can do that as well. Maybe let's add fillet before we do it. So I'll add a fillet of one here and one here. Click OK. And then maybe let's just add a center line as well here. So here we have the center line. Now I'll exit out of this sketch, features, and let's just revolve this. And this is the kind of feature which we are going to get. So it is just revolving it along this sine curve, and the result will look like that. All right, now let's take another example. So I'll just close this and I'll open a new drawing. Now, once again, if you want to make a 2D curve quite different using several different variables, well, you can do that. So let's go to sketch. And once again, we are just going to make a 2D curve, but this time using more variables. So in the previous example, I selected, well, explicit. Now let's select parametric. Now with parametric, you get more variables, actually two, which you can select from. Once again, I'm just going to use one of the ready-made formulas here. And the formulas that I have are these. So maybe I'll just select this, the equation for x, and then I'll select this equation for y. Now, right out of the box, it will show you this error message. The parametric equation, it should be expressed in terms of t, but I've got this unknown variable r that it is not able to verify, because we just need to add all of these formulas or equations in terms of t, because the t is the parameter which will change. So it should be expressed only in terms of t, but this is not recognized. We'll take care of it in a moment. But first, let's change the value of t from, let's say, 0 to 30. All right, and still SolidWorks is not able to calculate this because of r. Now let's change the value of r to 0. Now that's a number, and with that, we've got this spiral. Now, if you want a larger spiral, all you need to do is just change this value, just the range, and now we have a larger spiral. Also, this value of 0 or this r actually decides the kind of a spiral which we have here. So now this is Archimedean spiral. Now let's change that to a Doppler spiral, where the focus is kind of shifted on one of the sides. And for that, you need to use a value that is close to 1 for this variable. So I'll just use 0.9, but not actually 1, simply 0.9. And now I'll press Tab key. And here we are. So we now have this Doppler spiral at this place. Now I'm not using a value of 1 because with 1, it will intersect all of these curves right here, which may result in an error. So in this way, you can actually use different formulas for 2D to create the shapes like so. And here we are. Now, similarly, we can use equation driven curve for 3D. Let's use it. So I'll just exit out of this sketch and I'll close this as well. And once again, I'm going to start a new template. All right, now instead of 2D, I'll click the drop down and select 3D sketch. And now for 3D, we don't need to select a plane and we can start right out of the box. Now here I'll once again go to this equation driven curve, and since we are working with 3D, we now have 3 variables. So we don't have the option of selecting the parametric or the explicit, and we can directly start by adding our equations using these 3 variables. Now all the equations here should be expressed in terms of t, and then you can change the value of t, just like the previous example. So let's make a helix. And for helix, again, I've got this formula. So x, y, and z. Let's simply copy these formulas. And as you can see, everything is expressed in terms of t. So that's for x. That's for y. And then this one for the z value. All right. And let's use a parameter value of 0 to 10. So that's the range which I'm selecting. And this is the result. Now what we have here is a helical shape. Now if you want to change the size of this helix, that's here. So you can change the range to just make it larger. Now there we are. And if you want to change the pitch size, the diameter, all these things, then that's right here. So here I'll just change that to, let's say, 5 for this and 5 for this. All right, and here it is. So now if you look at it from the top here, the circle radius of this helix has changed. Similarly, for the z, I'm just going to change that to maybe 0.5. And here we are. Now we have this helix with smaller pitch value. So you can actually change all of these parameters simply in the equation and you'll end up with this curve. Click OK, and here's the curve. Let's see one more example of 3D sketch. And for that, I'm simply going to press Ctrl Z. And I'll just select once again equation driven curve. Now we have an equation for conical spiral that I recommend you try yourself, but here I'll just make a slinky using this 3D curve. So here I'll just copy and paste once again this formula. So I'll just copy paste it here, and that's the value for z. All right, and it looks like I just forgot to add the z value, so I'm going to type z equals right here, and here is an error. So it is 24xt and it will automatically highlight that error. So this is not x, this is actually the multiplication symbol. So I'll change that to this asterisk sign, which is the multiplication symbol. Done. And now there are no errors in this formula as well. Now, once again, you just need to specify the range. And I'm going to use a range of 0 to 20 for this. And the equation which we'll get will look like this. So now we have this slinky, which looks like a helix, but again, it is complete spiral here along the helical path. So these are complex curves that you can make using equation driven curve, which is otherwise not possible using the usual method.